Hi everyone, my name is Tim Skene. This talk today is going to address a question that people have been asking for a long time. Now, I'm not an astrobiologist or a scientist, but it is something I've always found quite interesting. Not the conspiracy theories about the government keeping alien secrets, but really from a more scientific point of view. My background is engineering, so I generally take a more practical and realistic view on questions like this. Are we alone? As soon as everyone knew about other planets out there arose stories about inhabitants of Mars and even Venus and Jupiter. Extraterrestrial beings are a staple of science fiction. There are all kinds of them. Sometimes they're rather nasty creatures, or, as in Star Trek, they can be just like us humans, except maybe a few details like pointy ears, and they might have no sense of humor. There are lots of popular books, internet videos, and TV programs about alien visitors, and they try to look scientific, although in fact all this stuff has just been made up. This talk is not about debunking all this stuff, but what I really want to do is to present what we currently know and what is equally important, what we don't know. One thing that we do know is that we have not ever seen any scientifically valid evidence of extraterrestrial life. And by valid evidence, I mean any artifact that's been constructed or left here on Earth, a UFO, or even a radio signal that could have come only from an extraterrestrial civilization. There is no evidence at all. And if you ask any astrobiologist or a scientist questions about life on other planets, a lot of their answers will simply be, we don't know. So if you are expecting a final definitive answer to the question, are we alone? There's really only one thing we can say with any real certainty, and that is, we don't know. But don't worry, that's not the end of my talk. And that's not the only question we can ask about extraterrestrials. There is actually a slightly different question on the topic, which is quite popular. And I'm going to present a possible answer to that question. You might have heard of it. It's called the Fermi Paradox. And it is based on the assumption that extraterrestrial civilizations actually do exist. Enrico Fermi was a very famous Nobel Prize winning nuclear physicist. He helped invent the atomic bomb and atomic fission power. His name became very well known in the 1950s. And the way the story goes is one day he was sitting around lunch with some other physicists and he said, well, you know, there's supposed to be billions of stars out there. There must be billions of planets. And there must be at least millions or thousands of other advanced civilizations. And yet we haven't seen anybody. So where is everybody? And this kind of got around and people began to wonder, well, yeah, that's a very good question. Where is everybody? So they began to write up answers, and there have been many explanations. Well, a lot of people said, yeah, but the aliens were here 5,000 years ago, and they built the pyramids, and then they left. Other ones say, well, no, they're still around, but they're disguised as humans. And I think those people like to watch the X-Files and that sort of TV show. Other ones say that, well, we're actually in a simulated universe run by advanced civilization. They want us to think we're alone. Other people say, well, no civilization ever gets to anything beyond very, very primitive life. And if they do, they don't last very long because they're just not around long enough. So there might be some truth to that, but that's not really the only valid answer. I have a book that's 400 pages about the Fermi Paradox, and it has 75 different answers. And some of them are a little bit more scientific, let's say, than others. But what I'm going to do is take a look at the scientific point of view. And this is an approach that a lot of scientists are taking. And they are happy to deal with what we know and also happy to say, look, there are things we don't know. so we only have to make assumptions. So what I'm going to show today is these three reasons, which certainly put together make a pretty feasible explanation of why we probably haven't seen anybody, and we may not see anybody for quite a while. First of all, the galaxy is very big, and we're just too far apart. And you probably don't have a really good appreciation of just how big unless you're an astronomer. So I'm going to try and get you to visualize that. The other possible reason is that civilizations that are really advanced could be very rare. We don't know how rare. Some scientists say we could be the only one in the galaxy. Other ones say, no, there must be millions, but we don't know anything more definite in between those two approaches. Something else that you have to try to be aware of is the cosmic time scale. We've only been around a very relatively short time in the cosmic time scale, but the stars and planets have been around billions of times longer. So that's something that also you have to take into account when you're thinking about who else we might bump into in this galaxy. I'm going to try to get that all of you to see that. So first of all, the galaxy is very big. Just how big? Well, the distances that we use in astronomy is the light year, which is the distance light travels in 1 year. And that's roughly 6 trillion miles. Now I'm using miles because we have some British and American attendees. They probably understand miles better. And I think most of us are old enough to know when we used miles in Canada as well. So let's use that as our unit. And it's very hard for someone to imagine a distance that they never really became familiar with. I think we can all say, yeah, something's 5 miles or 10 miles, maybe even 100 miles. But can anybody here imagine 1 trillion miles? We did not evolve to think about that kind of a number and that kind of a distance. So it's just a number to anybody. So I'm going to try to give you a little perspective. The distance from the Earth to Pluto. Now, you probably think, yes, that's a long way. We sent a spacecraft there, and a couple of years ago, it sent back some pictures, but it took several years to get to Pluto because it was on the very edge of our solar system. So you think, well, that must be a long way. You have to go 1,600 times that distance to go 1 light year, just to give you a bit of the scale. What about the closest star to Earth? It's 4.2 light years. You think, well, that must be a little bit past beyond Pluto, not too far. To get to the nearest star is 7,000 times the distance we have to go just to get to Pluto, just to get to the nearest star. So things are very far apart out there in space.
Okay.
What about the universe? How big is that? It's millions of times bigger than our galaxy. This is a picture which has actually become quite famous among astronomers. They took the Hubble telescope and they aimed it at a very dark spot in the cosmos, a very tiny little dark spot. And they left the shutter open for a long time to collect as much light as it could. And after quite a while, it made this picture. And those aren't stars you see, those are galaxies. And each one has billions of stars. But they're not just any galaxies, they are galaxies that were made way back at the very beginning of the universe. And they're many billions of light years away. And the light we see now actually came from them starting billions of years ago. Now that's a long way off. And that's only a tiny, tiny little fragment of what everything there is that's out there. And we'll probably, in my estimation, never get anywhere close to any of those galaxies. They're farther than you or I can really properly imagine. Okay, let's get to something a little bit closer to Earth. How about the Milky Way galaxy? And that's what you see every night. If you're in a dark area, you're going to see that across the sky. It's called the Milky Way. And It's got around 500 billion stars. Does anybody know how big it is? Just to give you a sense of scale. I was going to do another poll, but I just did the one, so I'll give you the answer. The Milky Way is 100,000 light years across. So that means if you need to get to a rogue planet on the other side of the galaxy and you're not in Star Trek, you can only go at regular speeds. And even if you can go the speed of light, it's going to take you 100,000 years to get across the galaxy. So that begins to give you a sense of the scale we're dealing with. Now, there's a little, very tiny little dot there where Earth is. I'm going to take that rectangle. Let's zoom in on the rectangle. And the green dot is where we are. There's a yellow circle around that. That represents a distance of 100 light years from Earth. And that is as far as any of our radio signals have gone in approximately the 100 years we've been making radio broadcasts. So for any other civilization to pick up our radio signals, they have to be inside that circle. And as far as we know, there's not too much inside that circle. There's a few things, a few stars and planets, but not a lot. The blue circle represents 1,000 light years. And if any civilization is within, let's say around near where the blue circle is, they will get our radio signals in another 1,000 years, not before. And the same going the other way. Any radio signals we pick up, they could have been made 1 million years ago, but probably more like 1,000 or 10,000 years ago, and we're only picking them up now, if we pick up any radio signals, which we haven't yet. And the other problem with picking up radio signals is they get weaker as they go long distances, so it's very difficult to pick up anything. So that there's not much out there, and if they're sending radio signals, they have to be pretty close and they have to be pretty strong, which is why we haven't heard anything. However, you may have heard the search for extraterrestrial intelligence. This is a project that's been going on for 40 or 50 years, and it uses big radio telescopes, and it tries to listen for any signal that might have been created by an intelligent civilization. And so far we haven't found anything, but it's an ongoing project. I'm not going to say too much about it. I have a few things here that people generally who know about it say that, first of all, it requires a very expensive kind of equipment. It takes just, if I go to the first point here, you need big telescopes and a lot of computer processing. Just a sec. It scans only a very tiny region of space. You can't aim those telescopes over the whole cosmos all at once. You can only aim them a very little way. It can only pick up all the noise that we get. We can't filter out intelligent stuff, so we have to figure out afterwards. And that takes a lot of computer power and so on. Its funding are inconsistent. The US government funded it for a while and then they stopped, and now there's some billionaires who will fund it off and on. Some scientists see it as a waste of money, looking for a needle in a haystack. That's true, but others feel that it's something we have to do. So I'll let you decide if it's whether the best way to spend money, but that is something that is ongoing. What about actually traveling to another star? Is it possible? Well, let's look first of all from the point of view of another civilization somewhere out in the galaxies. First of all, the laws of physics and the materials they have available are exactly the same that we have here. Nothing more. We know about all the laws of physics as far as they're going to affect space travel. We don't know everything about what goes on in space. We don't know everything, but we know about building a rocket ship and what the possibilities are. And we know what the chemical elements are. So building a spaceship which would go even 1/10 the speed of light is going to be difficult for anyone. And that means that if you have to go a very practical distance in the galaxy, which is many light years, maybe hundreds of light years, to get to somewhere interesting, it's going to be a complex undertaking because it's going to take a long time. So a lot of scientists feel that just like us, no matter how advanced they are, if they're going to make a voyage to a distant planet, they have to have the technology to do it, and they have to consider it a worthwhile to make a long, expensive expedition. So it's even possible that they could know about life on Earth, but they have to weigh the complications of building a spaceship to get there. How long is it going to take in terms of their lives? How much is it going to cost? And is it worth it? So we can idealize all we like about their political system, their society, how everything works, but it's still going to be complicated for anyone to get a long way. Just to give you a quick look at the possible ways that as far as we know physics, that you could actually propel a spaceship. The chemical rockets that we've used so far aren't very good for really long distances. They're good for sending satellites into orbit and so on, and even getting to Mars, but it's going to take 9 months to get to Mars because we can't go very fast. There's something called a plasma thruster. It sort of might work for long voyages, but it's not that powerful. It's possible to have nuclear fission or fusion to power a spaceship, but we've been working on that for 50 years just to get nuclear fusion to work down here on Earth. So getting it to power a spaceship is still going to be a big challenge. There's antimatter propulsion. That gives you the most bang for your buck. When you take a piece of antimatter and you bring it into contact with normal matter, they annihilate each other with an enormous release of energy. Unfortunately, that's both antimatter's advantage and its disadvantage. How do you hold a fuel tank full of antimatter without it touching any real matter and blowing the whole thing up? The other problem is that to actually obtain antimatter, you need a particle accelerator, which takes a lot of power to generate tiny little particles of antimatter. So it may work in some very, very advanced technology. And then if we want to go to the Star Trek type thing where they have warp drive, that actually has been calculated and made into a theoretical possibility. And what it does is you don't move the ship through space, you move space through the ship. You have such enormous amounts of negative energy, you can actually warp space-time around you instead of having to actually fly through it. Works great in Star Trek. They only have 60 minutes to get 100 light years away, so they got to have a fast way of getting there. Warp drive does the job. If that's ever practical, I'm not sure. All right, so just to give a last look at what we have to do to get somewhere in space. Let's say we build an interstellar spaceship in some future technology. It's got nuclear fusion power. It can get up to 1/10 the speed of light. So just imagine the power and the energy it's going to take to accelerate that thing up to 1/10 the speed of light, or 67 million miles an hour. And that's 1/10 the speed of light. So we set off for the nearest star, which has a couple of planets around it. It is 4.2 light years away, but we're only going 1/10 of light speed. So once we get up to our top speed, we sit back and wait 40 years. And once we get there, we got to flip it around and slow down again and stop. So we might explore a planet there for a while and maybe disappointed or not. Then we got to get started up again and spend another 40 years getting back. And that's just the closest star to Earth. So you get a little idea, I think, of the scope of the distances that we have to deal with. And that's just not for us, that's for any advanced civilization. So they may not quite zoom across the galaxy as easily as you tend to think. Now, how many advanced civilizations are there out there? Some scientists say we might be the only one because there are so many weird things that happen to make us who we are. Other ones will say, well, yeah, but there's all kinds of life that could be there. We don't know. For example, what do you have to have on a planet to be able to actually maintain life? You have to be in the right place in the galaxy, first of all. You can't just have life started anywhere in the galaxy. You have to be a good distance from a star, not too hot, not too cold. We'll look at that. Certainly for any kind of life that we know of, liquid water is essential. It's a basic component of how life works. We need to have a surface that's not just a densely compressed atmosphere like on Saturn or Jupiter. It's got to be a surface we can move around on, and the climate has to be stable so that we can adapt through evolution to a particular situation, particular conditions. There are chemical elements. We'll look at the chemical elements we as humans need, but maybe simple life could use fewer of them, but there are certain things that have to be there for life to work. We're actually, we have prevention of radiation like ultraviolet and other solar radiation from the sun through our ozone layer and through our magnetic field. And we don't get too many impacts from asteroids or massive solar flares, which could cause problems. So we're pretty lucky. That's why we're here. Now, the habitable zone around a galaxy, if you're right near the center of a galaxy, there's too many stars, too many things flying around, too much radiation. Life would not survive very long if you're right near the center. If you're in the green zone, we would be okay. If we're in the outer zone, there's not very many stars around. And it's the explosion and the death of old stars that creates a lot of the elements that we need. And if we don't have enough stars around that are creating that material, we don't have all the elements we're going to need for life. So life could be much rarer if you go too far outside on the galaxy. If we look at how we need to be in relation to a sun, if we're too close, it's going to be too hot. Like on Mercury, the water will all just boil off. If it's too far out, it's going to be all frozen. If the planet is too big, it's going to have too much gravity, and it's going to just attract a very dense gaseous atmosphere. If it's too small, the gravity will be too weak, and the atmosphere will get blown away. And that's what happened on Mars, which is much smaller than Earth, and it didn't have any protection from the solar radiation, and the atmosphere got blown away. Fortunately, we're in just the right place. Something else that, as far as we know, is essential for life is the presence of carbon, because carbon has a unique property that it can make all kinds of molecules with all kinds of other elements. These are organic molecules, and there are millions of different kinds of organic molecules that can exist. They have been detected in space. They've been found on meteorites that have come from space or from Mars. So those sort of building blocks are there, but that's not life. That's just basic molecules using some carbon. You need much more than that for life. For us, we need all of these elements. The main ones are carbon, oxygen, hydrogen, nitrogen. We need some of these other ones as well. And even very small trace elements, if we are suddenly really deficient on any of the trace elements, we have problems. So they're all play an essential role in life the way we find it on Earth. So let's go a little bit beyond the Fermi Paradox and let's ask a more complex question. And this is called the Drake equation. This was created by an astronomer, Frank Drake, back in 1961. And he said, well, instead of just asking where is everybody, let's try to figure out what we might be able to have to calculate who would be out there that might be able to send us some signals. And the text might be a little bit small, but I'll go over it one at a time. The first thing is the number we're looking for is the number of advanced civilizations in the galaxy. How many are there? And what would it take in the galaxy to be able to give us that number? So the first thing you need, how many stars are there? What's the rate of creation? What's how many of those stars have a solar system around them? How many of those solar systems have a planet that is suitable for life? That's this number. Of the ones which are suitable for life, on how many does life actually appear? And of those which actually have life developing, how many of those become actually intelligent life? And it depends how you define intelligent life. But he defined it as possibly being able to release radio signals that someone else could detect. And the last one there is how long do they last? Because life does not last forever. Nothing in the universe is permanent. Everything is temporary to one extent or another. So he thought if you put all of these numbers together, you could calculate how many there really should be out there. So I'll take a look at this slide, and I put in some numbers here and what we actually know in the calculation of doing something like this and what we really don't know. For example, he puts rate of star generation. Stars come and go. They don't last forever. So we put it that way, but that's also similar to what are the number of stars we have right now. How many have a planetary system? Well, in the last few years, we have known an awful lot about that we didn't know before. So we can put a number there based on a lot of results we've seen from special telescopes. How many of them are habitable? We don't know for sure, but we can now estimate a pretty good number. How many of those might have habitable planets? How many are going to have life on them? We don't know that right now, but I'm going to show you how in a few more years we're going to actually be able to tell if there is life on a planet. So we will know that in a few more years. However, how many have advanced intelligence? There's no way we can tell if any advanced intelligence is existing on a planet. There's no way we can know, and there's no way we will know, maybe until we visit. So that's a big question mark. How many send detectable signals? That's another big question mark. We just don't know. How long will a civilization last? Again, we just don't know. It could be 1,000 years, it could be 1,000,000 years. So what I did was I put some reasonable estimates. People do this using various estimates. The first one is we have 500 billion stars. We know now, recently, that we can say with a pretty good certainty that on an average, every star has a planetary system revolving around it. And on average, again, I guess we're going to be learning a lot more, but let's say 1 in 10 is habitable. And of the 1 in 10 that are habitable, let's make a wild guess of 1 in 1,000. But in another 10 years, we will have a very good idea because we will have found which ones might be habitable. So we put in 1 in 1,000. Now, if they are intelligent, we don't know. So let's say 1 in 100. that actually have life, it becomes intelligent. If they become intelligent, they'll make radio signals, so let's say 1 in 10. And if they last 10,000 years, what that really says is if we go back and we take 500 billion stars, that would mean we have 1/1000th of that, or 500 million civilizations that can send out radio signals. Now, a lot of these numbers are wild guesses. It could be 1/1000th of that, or even 1/10,000th of that. Something that Frank Drake didn't take into account is the fact that for us to hear something, we have to be close enough. And if a civilization starts broadcasting signals on the other side of the galaxy, we'll never hear it. So he didn't take that into account for some reason, but there is the distance factor. Anyway, people are trying to make estimates. You can take them seriously or not, but at least we're trying to look at what we know and what we don't know. And this sort of sums up what we know and don't know. Now, how have we been discovering distant planets? In the last 10 years, we have discovered a lot of distant planets around other stars. They're very dim, very hard to see. And to be honest, any astronomer will tell you, until 10 or 15, 20 years ago, we didn't know there were any planets. They had no idea. But in the last few years, they have come up with ways to actually discover and verify that there are planets around most of the stars, the one that we've looked at. The way they do this, actually, I'll go back. The way they do this is, first of all, detecting a wobble in a star's position. If a star doesn't stay in the same place, but it wobbles back and forth, it means there's a big, heavy planet orbiting around it, because their gravity is attracting one to each other. The other way is observing a transit, which happens occasionally on our own solar system when Venus might cross in front of the sun. But for observing planets on external stars, you see that there's a planet. When it goes in front of the sun, it darkens the light from the star a little bit. We can't see the planet necessarily really precisely, but we know that there's something that passes in front on a regular basis. So what they have is a lot of very specialized telescopes. This is one of the first ones that began to look strictly for planets around stars. This is the Kepler telescope, which launched 2009. It has found thousands of planets so far, circling around many different stars at different distances. This is called the TESS Transiting Exoplanet Survey. This is more recent. They expect that one to find thousands more stars. So I have a little video here I'm going to show. Whoops, just a sec about this. So here we go.
NASA's TESS mission has found its first Earth-sized world in its star's habitable zone. This means the planet, called TOI 700d, has the potential for liquid water on its surface. TESS stares at patches of sky for long stretches, recording light from thousands of stars. Some of these stars have planets that cross or transit in front of them. TESS sees these events as tiny, regular dimmings of the host stars. One star where TESS saw transits is TOI 700. It's a red dwarf about 40% the mass and size of our Sun and roughly half its temperature. One set of transits announced the presence of a planet close to the star, called TOI 700b. Another set revealed a second planet named TOI 700c a little farther out. The deeper, shorter transit means the planet is larger than the first, and the plane of its orbit is slightly tipped. A final set of transits showed TOI 700d orbiting even farther out. TESS observed this system for nearly 11 months and saw each planet transit multiple times. Scientists determined that the inner and outer planets are almost Earth-size and may be rocky. The middle world is more than twice as large and most likely made of gas. All three may be tidally locked, rotating just once each orbit, so the same side always faces the star. But most importantly, TOI 700d is within the star's habitable zone. Scientists wanted independent confirmation of TOI 700d, so they monitored its star with NASA's Spitzer Space Telescope. Spitzer saw a clear transit from the outer planet, affirming its existence and improving scientists' certainty of the planet's size. TOI 700d is one of only a few Earth-sized planets found in potential habitable zones. Others include discoveries by Kepler and several planets in the TRAPPIST-1 system. Because TOI 700 is bright and nearby, the planets are good candidates for precise mass measurements by ground-based telescopes. Future missions may also tell us if the worlds have atmospheres, but scientists need to know what kinds of signals to look for. Researchers at NASA's Goddard Space Flight Center created models of the planet to explore its potential conditions. One version is a water-covered world with an atmosphere similar to early Mars, but denser. Another looks like a completely dry version of today's Earth. Both models have vastly different surface temperatures. Light passing through their atmospheres creates distinct signals because different molecules are present. By simulating these data now, scientists can make predictions for real future observations and narrow the range of TOI 700d's possible conditions. We still have much to learn about the TOI 700 system, but thanks to TESS, Spitzer, and the work of many scientists, we're beginning to form a picture of its exciting new worlds.
This is another telescope which has been set up recently. Its job is not to discover new planets, but to examine and find the details and characteristics of ones that they've already found. So research in the next few years is really going to be ramping up on discovering planets and discovering what might be on them. So in the last several years, over 4,160 confirmed planets have been found. They've pinpointed 21 which are potentially habitable for life. We don't know yet if they have life. We have to look at them more closely to see if there really is life there. But if you asked an astronomer 15 or 20 years ago, how long would it take to know all of this? They would say, we may never know all of this, but now we know all of this information. So it's really made a big advance in astrobiology and astronomy. And what we will be doing in the next few years is detecting life on the planets. So biosignature gases are what they mentioned in the video. If you use various spectrum analyzers and special telescopes, you can see what's going on a planet. And there could be cases where there are gases there that only could have been created by life. There'll be new telescopes which are going to be looking for that sort of thing. The only example we have is on Earth, and we have a pretty good idea of the different phases that Earth's atmosphere went through in evolution over the billions of years. And the only thing that the scientists are going to find very frustrating, they're going to discover that yes, there looks like there's life on a planet, almost 100% for sure. I would really like to visit that planet. The only problem is it's 100 light years away. So that's going to bring new discoveries and new frustrations when we start to find things like this. All right. The cosmos is undergoing constant change. Nothing is permanent. Let's take a look at geologic or cosmological time. The universe began around 13.5 billion years ago. Stars are not permanent. They come and go. They're born, they live a certain life depending on the type of star, and then they die. Our sun is a relative newcomer. If we're still around in 5 billion years, we'll be in trouble because our sun is going to blow up and disappear. Life on Earth has existed for about 3.5 billion years. That's only a small fraction of how long the universe has been around. We might think that humans, if we go back on the history of humans, that's a long time, but that's just a mere blink of an eye in the life in the evolution of life altogether. So for example, there could be a planet, let's say this planet here, which was formed and developed life 8 billion years ago. There could have been advanced civilizations which developed on that planet, and they might have lasted 1 million years or 10 million years or 100 million years and become extremely advanced. But that was a few billion years before our planet was even formed. So they could have come and gone a long time ago. So you can't think of everything happening all at once when you think of how many other civilizations might be out there. You have to think in terms of the cosmological time scale. Let's look at how life developed as far as we know on Earth. Now the Earth is around 4.5 billion years old. It went through a few interesting things. At this point, the moon was formed by an enormous asteroid that hit the Earth and formed the moon. But soon after that, if you look at when the first evidence for something on life, now it wasn't life itself, but evidence left behind by some kind of life being there, actually started relatively soon after, first billion years, and it developed throughout this period. Very primitive, very simple life. But one of the things it did was the atmosphere was very different at that time. In fact, what it used was carbon dioxide to breathe, and it, as a waste product, created oxygen. And eventually, the amount of oxygen in the atmosphere became so much that those original primitive types of life died out, and more complex types of life began to form because now they had oxygen, which was much more reactive. You could do different things with oxygen. And the first multicellular life formed, then the first cells with nucleus and so on. And then only relatively recently, around 600 million years ago, the really complicated life began to form. And from that point, we have fossils, and we can track it very closely. And then eventually, the dinosaurs came along, and they lasted for quite a while. And then very, very recently, in the cosmological blink of an eye, primates and humans like us formed. But us forming on Earth as a type of advanced life was not simple, and it was not quick in terms of the overall scheme of things. If we look a little bit more closely, we're going to look just at this last part in the next slide for the last 600 million years or so. And that's when life really began to take off on Earth. But look at the top of the slide. Life is uncertain. I have a friend who has a favorite saying: life is uncertain, eat dessert first. We've had 5 major extinctions. So our life has kind of undergone a reset 5 times. At the beginning, there was a lot of life, a lot of types of species that grew, and then suddenly it dropped for some reason. We're not sure about these different extinctions. Some of them are due to perhaps an asteroid impact, super volcano. There were changes in climate for various reasons during the shifts that the atmosphere was going through, but we had a big extinction then. We had another one around 350 million years ago. There was a big one at around 250 million years ago, where a lot of species just died off. And then after one they called the Triassic extinction, then the dinosaurs got started, and they grew in number until they really took over the Earth. And if it wasn't for a bad day for the dinosaurs and a good day for us, 65 million years ago, an asteroid hit the Earth and wiped out the dinosaurs. And the dinosaurs have been around for 130 million years, and if it wasn't for that asteroid, they might still be here. So that wiped them out, and that caused the mammals now to be able to evolve and develop much more than they could before, because they kind of got eaten up by dinosaurs. And so that gradually came up to where we are now. And there was actually an ice age about 12,000 years ago, which caused some extinction, but we all lived through that. So life is not certain. There are a lot of things that could happen to cause life to take a reset. It may not destroy all of life, but it could destroy certain species of life, or certain types of life, and you have to kind of start all over. So that has actually happened. So let's look at the possible causes of human extinction. And don't worry, they all are very low probability, but some of them have already happened in the past multiple times, and they caused extinctions. Asteroid impact, a dinosaur can tell you about that one. Excessive climate change may have happened several times during the development of life on Earth, and a lot of species get wiped out. Supervolcanoes have happened. There are a few supervolcanoes which in the next few hundred or thousand years are expected to erupt sometime. They're kind of past due. Nuclear holocaust, I hope we don't have that one. Unsurvivable pandemic, well, we know all about pandemics nowadays. This one I think is survivable, but maybe the next one, who knows? There could be big eruptions on the sun, which could cause, first of all, a complete disruption of our atmosphere and electromagnetic pulses and various things that could cause problems. Any of these could happen. And if you look at the next 1,000 years or 10,000 years or 100,000 years, there's a very good chance over that period of time, one of these might happen. We've only been here a tiny blink of an eye in terms of the time scale. So, all right, so that kind of sums up, first of all, to answer Fermi's question, where is everybody? Well, our galaxy is very big and we're very far apart. So no matter what technology you have, if you're 1,000 light years away, that's going to be a challenge. We don't know how often an advanced civilization actually develops. We can make a guess at 1 per galaxy to 1,000,000 per galaxy, and any guess in between is just as good. There are a lot of very unique things, very specific things that happen on Earth to make us into who we are. So if you're looking for another planet that is just like Earth, and you land on that planet and you find humans that look exactly like us, except maybe they have pointy ears and no sense of humor, don't expect to find that. Because every planet is truly unique. And life is not permanent in the universe. Things change. Stars come and go, galaxies even come and go. And life is a far more vulnerable thing than stars and galaxies. So there are lots of reasons why we haven't seen anybody. To answer the question, are we really alone? Well, the only answer you can really give with any certainty is we don't know. And maybe we never will. Anybody who thinks otherwise thinks they know more than they do. So we could effectively be alone. Maybe there are a million other civilizations out there who have come and gone or in different stages, but they're just too far away. It's too difficult to signal someone else or to actually get to someone else. And so we may, who knows what we're going to discover in the future. If you mean by alone, just a primitive type of life, we may find something. But if you mean all the different types of life we find in Star Trek and Star Wars and science fiction, we may not. So, but the only best answer you can really give is we don't know. And that's an answer that scientists are very happy to say. if you do, I saw a lot of interviews with astronomers and astrobiologists, and the interviewer was asking them all kinds of questions, and the astronomer was perfectly happy to say, "We don't know." The problem is a lot of people who are not scientists aren't like that. They get very bothered by not knowing something. So somebody makes up an answer and puts it on the internet. And that's the development, genesis of conspiracy theories, that aliens have visited us and done this and that and all sorts of things. So that makes people feel a little bit more secure that we know the answer. But if you're a true scientist, you're going to be perfectly content with not knowing, because that's the way it is, and you're going to try to spend your time finding out. All right, so that kind of wraps it up. Thank you. If you have any questions, maybe we could take a little break, and then we'll have some questions and discussion.
I've always, I wasn't sure about Dr. David Greer, who is involved with the SETI Institute. I don't know if you've known, but he has put out a guide on how to contact extraterrestrials, and he's doing it by mass meditations. So I've stopped following him. I still meditate though.
Well, meditation is one thing, but mind melding is something else.
Does SETI have their own telescopes, or do they piggyback on some people?
I'm not a real expert on it, but what I've seen is they have some setups. One in particular that Paul Allen, the Microsoft billionaire, funded in Arizona, I believe.
Okay.
And they also use time on other telescopes as well. The one they set up in Arizona covers a big field with specific types of telescopes that they use for this purpose. And something else they do is the signals that they receive have to be analyzed for trying to decipher any type of signal that's repeated or could be non-natural. And you need computer power to do that.
Right.
So they have something called SETI at home, where you can volunteer idle time on your computer to process the signals.
Amazing.
And it takes artificial intelligence and various other things to try to figure out what is natural and what is not natural. And a few times they've come up with something that definitely looked not natural. And then you looked a little closer and they said, oh, it's this pulsar over there that's causing this repeating signal, and so on. So nobody knows what they might or might not find, but there are people who will fund it, who have enough interest in it. They'll say, well, we should be doing something.
Mm-hmm. Interesting. But I have to say one thing though. I am a stargazer, and I have a software called Night Sky, which shows me all of the constellations and the stars as much as I can see, and it shows me the satellites, and it tells me at least what number they are, and sometimes I can find out what their specifications are.
Yeah.
2 nights ago. Now, maybe it's because I've been working so hard with you on this. I thought I saw something, just a round light go by. It was just off my horizon. I put my iPad on it, which is where I have the software, and it should, and it did not pick up the signal from this light. So like you say, we don't know.
What do you mean pick up signal?
Well, the satellites, I usually see the satellites and I usually get their name. But when I saw this light go by, there was no name given to it.
Oh, okay. It shows where you're looking and it shows everything that you should see at that point.
Right, and it also tells
Yeah.
me the satellite number.
Yeah. Okay.
So anyway.
Well, if you want to talk about UFOs, that's a whole topic by itself. But
yeah.
part of the problem is that there could be all kinds of things there. It could have been a meteorite, first of all. It could have been a satellite that's very recent because they keep putting them up all the time that wasn't identified in your software. It could have been a plane. It could have been all kinds of things.
Well, planes I know.
Yeah. Just because it doesn't show up on your program on your iPad does not mean it's visiting from another planet.
Okay.
Okay.
Makes sense.
Yeah, I agree there. I mean, like you said, it could be just something that was not named.
Yeah.
Yeah.
And that's what UFO actually means. It says unidentified. It doesn't say extraterrestrial. It says we don't know what it is, but that doesn't mean it's this particular thing.
Yeah. This is amazing. Just amazing. Do you think that artificial intelligence would be able to come up with something to make interplanetary visiting quicker, faster, more efficient? Because from what I read about AI, once it starts and takes off, apparently it can build itself and learn things itself. Who knows?
Yeah, I've studied that a bit. I gave a lecture on it once, so I know a bit about it. Yeah, it can at some point maybe be able to improve itself, but a lot of the problem with the term artificial intelligence is that people see the word intelligent, and even though they know it's a computer, they tend to begin to assign human behavior to it.
Right.
And the people who actually work in machine learning and neural networks and so on know that it's a long way from actually having an inherent human behavior. But people who don't know so much about the machine learning and the types of systems they're using, they see that word and they say, well, I see it's going to be like a human. And their thinking is partly influenced by science fiction they've seen.
Yeah.
And then partly by the word intelligence, which says, well, we must be intelligent like humans. So they begin to make all kinds of predictions and have great fears, but the people who really work on it know its significant limitations as well.
I see.
Tim?
Yeah.
Go ahead.
How far up have the astronauts gone, the furthest they've gone up? How?
Oh, the furthest they've gone is the moon.
But how far up is that?
240,000 miles, I think it is, or kilometers. It's the farthest we've gone because we've never made a trip to any specific place other than to the space station and fixing the Hubble telescope and that sort of thing.
And Mars is much further?
Much further.
Okay.
I think any estimates I've seen, if they get it just right, it's going to take 9 months to get to Mars.
Okay. And another question, and last one. Trump is talking about a space army. Why?
I was hoping we could leave Trump out of this discussion, but that's okay.
No, we can't.
Space Force, I wouldn't put too much credence on whatever comes out of Trump's mouth, but
there is a plan apparently.
There is a for some kind of space force, which may just militarize, put certain military satellites and weapons even in space. I don't think it's any more than that right now.
From what I understand, this is not completely Trump's idea, but there is a concern by the American military and the American intelligence that the Chinese, who can develop so many things very quickly, will completely take over what's going on in space now and could control different things.
Yeah. They've got a pretty active space program going on. So yeah, we'll have to wait and see. I think they're just using it to show off, but probably the Chinese would use it for spying and picking up intelligence on what's going on everywhere for sure. Yeah. Okay, we have some questions here on the chat from Margaret.
Yes.
Is there any kind of concept of what existed before the Big Bang? If nothing, how does one define nothing? Well, actually, that's a very good question. And again, I'm not a cosmologist. I did read one book called A Universe from Nothing. Yeah. And I've read a bit about it from other scientists, physicists, and so on. And the way I understand it, there never really was nothing. Because of the basic principles of the physical existence, there must always exist some kind of an energy balance between positive and negative energy, just for very existence to be there. Now, don't ask me how to explain it, but there never really was a true non-existence, let's say. There always was some kind of negative positive energy balance always existing.
Yeah, it's kind of hard to wrap your mind around it because it's knowing how huge the universe is, almost infinite. It's a very difficult, for me, always has been a very difficult concept to understand, you know, exactly what existed before.
I don't understand it.
I posed the question.
I don't understand it, but this is the explanations that I've seen.
Yeah.
And what happened was just suddenly, and I couldn't say just one day or one time because time was not the same. Time and space were not as we know them now. Time and space are related. They affect each other. So they were not the way they are now, but something happened which caused this to react. And the first reaction was some kind of just an energy imbalance. And then things began to form from this imbalance, which caused the physical materials, physical hydrogen atoms that we know about, or elementary particles, and so on and so on. And that really was the beginning of the Big Bang, where the matter and time formed the way we know it now.
Right.
But what caused it, they don't know.
And never will, I'm sure.
And maybe never will. Because we can't go back to before then, because there was no before.
Right.
Okay, Peter Roberts. Any guess why people want to know if humanity is unique? Any reading to suggest? Well, I have to think what books I have. If humanity is unique, well, we don't know if humanity is unique. And we don't, we are unique in the sense that no other planet could have formed just like us, because there are just way too many variables that all came together in a almost purely unique way. I'd have to see what books there are on the question of extra terrestrial life or exobiology. It's a big area of study right now, and scientists are studying life in extremely inhospitable locations right on Earth to try to get an idea of where they might start on other planets. But to answer that question, we don't know enough to answer the question right now. We may, in a few more years, begin to learn that other planets they have some kind of biology or life, but beyond that, it's going to be hard to answer that question. Okay, from Ali, how are the concepts of life and intelligence defined in the Drake equation? That's a good question as well. In fact, there is debate among scientists. How do you define life? And I think in Drake, when he made his equation, he was just concerned with, well, whatever it is you need to make radio signals so that we can hear you. So he said primitive life and then intelligent life. And you might say, well, how do you define intelligence? Well, that's a whole other question too. So if we go back to the Drake equation, he just said primitive life, and then the next stage was intelligent life. And how many primitive life planets developed into intelligent life planets? That's all he said. So you can, there are lots of books on that type of thing. I'm sure you can find something that, how do you define life? And astrobiology is a whole field in itself on the whole idea of what kind of life can develop on planets and what conditions and so on. So that's a good question. Mike Braca, what is your opinion on Roswell? Well, I think, as you may guess, I like to follow real facts and scientific evidence. And if you look at the actual scientifically valid evidence on whether an alien spacecraft crashed, and if there were alien beings that they took out, and there was alien technology and so on, like many conspiracy theories, you're going to see stuff on the internet that may look kind of scientific to the uninitiated. And they're going to have books and videos and all sorts of things on it, and even TV programs on the Discovery Channel on what aliens did and so on. But if you dig down a little bit deeper to find the source of where that came from, and you dig a little deeper and a little deeper until you get to a dead end, and you're going to find that somebody just made it up. Whereas if you don't know the difference between what's pure science or proper and what's not, that's understandable. There's so much junk out there, it's hard to tell. The way to tell is to follow to the source of where it came from, and that may give another source. So if somebody says, oh, the earth has this type of condition, et cetera, and you don't know if it's true or not, try to do a search. You will find articles, you will find videos on YouTube. If it's really true and it's supported by a lot of scientists, you will find more scientific articles and publications and videos than you will ever finish in a year on that topic. That means it's true. It may not be 100% accurate. It may vary a little bit, but it's something scientists are interested in studying and coming up with real evidence for. But if you go a little bit deeper into whether the earth is flat, you won't get very far, because you're going to find stuff that people just made up and put on YouTube with nothing to back it up.
Okay, thanks.
Playing the devil's advocate from Ali, given the poll results, where does God stand in this scheme of things?
Good question.
That question cannot be answered in the few hours we have left. I'll put it that way. I could discuss, where does God stand? Are you an atheist, Ali, or are you a religious believer, or you are kind of on the fence, or the whole topic of God? There are people say, well, it's all just an invention. Other people say, well, we could not be here if there was no God, and they're firmly convinced of that. And everyone is somewhere in between those two places, and you could discuss any one of the positions in between. Something that does come up quite occasionally is, what if we do find life on another planet? How does that disrupt a religious dogma? And look at the question of evolution. When Darwin first discovered evolution, he was really rejected by religion and the Pope and all the Christian, and Islam and all the religions said, no, we were created by God in 6 days, etc., etc. Eventually, the Roman Catholic Church came around to accept evolution because the evidence was so compelling. And a lot of other evangelical Christians don't accept evolution at all. They say, no, it's like it was in the Bible. But the Roman Catholic Church came to accept it because it made so much sense. As long as God was kind of directing things behind the scenes of evolution, then evolution is fine the way we study it. So the same thing if you find something on another planet. They might find evidence of a very primitive life on another planet, but they're not humans. They're us. We have only other humans have a soul. Some bacteria on another planet doesn't have a soul, so that's fine. They can exist. Okay, so it all depends on your religious dogmatic point of view. Liliana, is there any chance that humans could form a colony on another planet? That's a good question. There's lots of talk about it, but as I mentioned, getting to another planet which could be habitable for humans is a whole big problem in itself. Just getting to Mars is going to be a major undertaking. It's going to be very expensive. It's going to be very risky. They talk about making a colony on Mars, but if you look at the complications and expense and the payback of doing that, it's really hard to say. A lot of people say, yeah, we'll send a few people there. We'll discover everything that we can discover. And just like the moon, we're going to say, well, we found out everything we can find out. It's not worth it going back so far and risking people's lives so much. Getting farther than that, as you saw in the presentation, getting even a few light years is a major, major undertaking. And to find a planet that we could actually just land on and live right away like they do in Star Trek, we don't know if we'd ever find a perfect planet. Certainly probably not very close if we could even look that far. So colony is a nice idea, but you got to be practical too. So it's really hard to say.
Can I just mention? Oops,
yeah.
sorry, go ahead. Just want to mention, I get all kinds of crazy things on Facebook and regarding ETs and AM and FM and whatever. What I do is I go to the NASA website, and then that will be very up to date, very clear. And if what they put on the website is what they put on Facebook is not on the NASA website, well, I completely discard it then.
Yeah. Yeah. So yeah, there's a lot of free information there. That video was from NASA, and you know, they're very serious people there. They really are trying very hard to deal with what we don't know and trying to find out what we can find out. But okay, Laura Grunberg has a question. Given the size of the cosmos, wouldn't it be statistically highly improbable that we are the only form of conscious life in the universe? Well, that's perfectly true. Yes, as the Drake equation tries to put it into some numbers, it probably is statistically improbable that we are the only form of conscious life. So, and we have enough evidence to make that statement. Yes, it is highly improbable that we're the only form, but we don't know any more than that. So we can't, in science, you want to have real evidence that you can examine from every angle and come to a firm conclusion from. And we just don't have evidence we can examine closely enough to come to any conclusion yet. So we have to, that's one of those things that we can make guesses, but we don't know more than that. So we will learn more after they begin to examine some of these exoplanets where they can see what's going on in the atmosphere. They can say, yeah, this planet looks like it has life of some kind, which could cause that type of atmosphere. But you're looking at a planet that's many, many light years away, and all you can do is kind of look at the color of the atmosphere and the colors that refract through the light and so on, and make guesses, good guesses as to what's there. But if you look at Earth from several light years away, you'd see the same thing, and you wouldn't know what's going on Earth. In fact, even look at what we see from the space station. We see the geology in the oceans and the clouds, but you have to be a lot closer to really see what's going on. Yeah, Howard?
Basically, we are carbon-based. Now, some years ago, I read something about the possibility of a world or people that are silicon-based. Have you heard anything about that?
As a matter of fact, I saw an article where recently some scientists did a study on that. And I might have it on my computer. I can send it to you if you like.
Oh, sure, please. Yeah.
And they went through all the possibilities of what life really needs to be life.
Right.
And they tried to see if silicon could replace carbon, and they say no, it probably could not, because silicon can just not do all the things that carbon can do.
Okay.
So that was one study. It may not be the final word. What does seem true is that carbon is the most likely basis for life, because it's pretty prevalent everywhere in the planets and in the galaxy. And organic molecules then happen with different other elements.
Right.
But you need more than that for life to actually start. And that's the other question. If any of you there would like to win a Nobel Prize, come up with the exact explanation how life got started on this Earth. And they've been put forward lots of ideas, but we weren't there to examine it happening, so we have to just guess at what might have happened. Anything else? All right, if you like, I have put in the chat if you go into your chat window, there is, and mine is part way up, there's a PDF, arealone-lecture.pdf. And that is the PDF of the slideshow, and there's a link on the page to the video.
Wow.
Okay.
So if you click on that, it will ask you to put it somewhere on your computer.
Okay. In the interim, there's a fun thing that a couple of us do, is that you can watch the space station, the ISS, go by.
Oh yeah.
If you go to the NASA website and type in spot the station, and you put in where you live, it will tell you when it will come by. Tonight is coming about 11 o'clock. But anyway, it's a fun thing to do, and it's interesting. Yeah.
Yeah, I mean, I've seen it once or twice. You have to be at the right place at the right time.
Yeah.
And no clouds. Would it be pretty well directly overhead, or to one direction or another?
It varies. Usually it's going from west to east. Then it changes to northwest to southeast, and it does change around.
But I think every within a certain north and south latitudes, it covers almost everywhere on the Earth at some point or other. Yeah.
Exactly. Yeah. Exactly. But it's a fun thing to do, seeing, that you can watch the spacemen do spacewalks on the NASA site, and then look around and see the ISS go by. It's fun. Yeah.
Sorry about that.
No worries.
We'll check on that in the future. Any more
Tim.
questions? What from Liana? What's the relationship between carbon and water? I'm not a chemical expert. Water is hydrogen and oxygen, H2O combined.
Yeah.
How they would combine into an organic molecule with carbon, I don't know. I have to say that's beyond my pay grade, that question.
We'll need Dr. Schwartz.
We need Dr. Schwartz can answer that one, yeah. The carbon will combine with lots of other elements to make organic molecules, but water is already a molecule. So what they would do to each other, I couldn't say.
Carbon with oxygen is carbon dioxide.
Yeah, carbon and oxygen, carbon monoxide, carbon dioxide are two gases.
What about carbon and hydrogen?
There are
I've seen
some
that. I've seen that, yeah. I don't remember
combinations.
exactly what it is, but I've seen it. I just don't
Yeah,
remember the particular one.
Carbohydrate.
Yeah, those pictures of organic molecules, don't ask me what they were. I just found some pictures of organic molecules and put them there just as examples. I did find that, strictly speaking, there's some 9 million different organic molecules that you can make with carbon and other elements that are a complete molecule, and even DNA and all the biological molecules are organic molecules. Okay, any more questions? We have legally till 5:30 if you like, but I hope everybody enjoyed the
Oh boy, oh boy, oh boy.
presentation.
Yeah, it was very-
Thank you.
There's a survey that is supposed to be sent out tomorrow.
Yeah.
So you can put your comments in there. I got a survey today from McGill. Maybe that's the one that was supposed to be sent tomorrow. So if you get a survey for whatever lecture, you need to answer a different survey for each lecture you saw, because you put the name of the lecture at the top and send it in. So anyway, put in whatever you liked or didn't like.
So Tim, I have a question.
Yeah.
All these sightings that we hear about, and there have been a lot, those are all fake news?
Yes. Well, they're.
That's
You know what?
definite answer.
During the 1970s and 80s, it became much more of a craze, and all these photographs turned up of things flying through the sky that kind of were flying saucer shaped, and so on. And nowadays, in 2020, everybody has a camera in their pocket. They even have Photoshop in the camera or on their computer. They could make up the most fantastic looking pictures and send it into YouTube or Facebook and say, I saw this. And you know what? Nobody has found any pictures of any extraterrestrial flying saucers since then. So the craze has kind of died out, making up fake pictures. But it's very common to see things that you don't know what they are, but that does not mean that they're a flying saucer. It just means you don't know what they are.
Okay.
To be scientific, you would have to prove that it could not possibly be anything else except a flying saucer from another planet, to be scientific.
Wasn't there, I think it was last year, there was a group of people that were going to charge Area 51 in the United States?
Oh, yeah.
Do you know what happened?
Yeah, there was.
I didn't hear anything about it.
Did they go finally?
I think 1 million people signed up, and then about 100 people actually showed up or something. got turned away by the security guards. I don't know. Nothing spectacular happened in any case. And incidentally, there's the Roswell Museum, the UFO or the extraterrestrial museum in there, and Martin actually visited it, and he had a good time. And it turns out that that museum, which is devoted to the UFO idea, it's the only museum in the world which is devoted to a particular type of civilization, which has absolutely no artifacts or samples of any kind of the civilization which it represents. All the other museums do have something from what they're trying to show, but they're all on Earth, of course.
Professor Don Dondary every
Yes.
so often gives a course on, I guess, ETs, extraterrestrials, or spacemen or whatever. I took it. It was very interesting, but I'm still not convinced.
Is anyone else here taking that?
Yes, I did.
Yeah.
It was very interesting, actually.
If you're not a scientist or real critical thinker, you could be fooled by that, and you could say, well, is this really true or is it not?
Especially when you have people in the class who claim that they have had sightings. And quite a few that claim that they had sightings. And, you know, I mean, who am I to say that they're lying?
Well, there are lots of things that show up in the air, flying around for one reason or another, and maybe with drones and that sort of thing, maybe more. And then, but the human mind is a little bit irrational. It's a little bit unstable at times, and things can be made up, hallucinated, and so on that maybe really weren't there, but you get really convinced that it was there, particularly if you believe in something that might be there.
Howard has a question.
Yeah. Howard.
Okay, in 2017, 2018, there was kind of like a spinning cigar type of rock that came in from outside of our universe.
Yeah.
It came in, and when it came near to the sun, it did an absolute right angle up. It didn't follow a normal path. And nobody knows why. That's interesting. They've called it what's called Oumuamua.
Yeah, it's got a funny name.
Yeah, it means, what does it mean? Spectator or something?
Yeah, it's like I read a bit about that, and they, some people said, oh, it must be an alien spaceship to do what it's doing, and but they didn't discover it until it had gotten past Earth and it was going around the sun, I think. And they looked at it. There are lots of pictures of it, but it looks just like a rock, and it could happen. A rock flying through space for whatever reason is going to keep going until it gets influenced by gravity or something somewhere and fly around the sun. But there's no evidence that really suggests very strongly that it's an alien spaceship.
Right.
Incidentally, that's one of the things you have to watch out for. If you're flying in your spaceship at 67 million miles an hour, you don't want to hit anything.
Well, you have to put up your shields.
Oh,
Your phasers.
There's no shields that will, even a tiny little speck will cause a problem at that speed.
Yeah. Oh, yeah. Well, those walls are not very thick.
No.
Just to be practical. They said in the lunar module, you could kick through the module itself, kick through the wall.
Oh, it was really, yeah. Well, they weren't out in space very long. Anyone else? Mark Cole, did you put your hand up? No? Okay. Looking at the chat here, there's Is there any relationship between you being a believer in UFOs and being a Trump supporter? Let's discuss this in the post-mortem. Well, all I can say to that is, yeah, you're the kind of person that will believe anything. So, that's all I can say. That's on that. No, there is a lot of psychological work done on things like conspiracy theories, why people believe them, why they like them. There's a whole documentary on Netflix called Behind the Curve on the Flat Earth Society. And it's very interesting because people who, let's say, had a lot of trouble with science and things were never very clear for them. And then they find something that now they're an expert on, that they really know about. It makes them feel very secure, gives them some certainty. And the other thing is, if maybe they had social relationships problems with a few friends and so on, they find an organization that believes the same thing they do, and they have get-togethers and they have parties and so on. They gave them a whole new lease on life to believe in something like that. So that's part of conspiracy theories. And what it does psychologically for people has been studied, and they say, yeah, it makes them feel certain about something. It makes them feel they know something, whereas they didn't know much before. Yeah, Frank?
Just to be controversial, is there any relationship between belief in UFOs and religious belief? Just to be a little controversial.
I think if it depends on how devout a religious believer you are, and you probably, if you really believe in a literal interpretation of the Bible, then God would not have made other humans, really no other creatures that is comparable to humans with souls and so on. But I did read an article a while ago, I think it was in New Yorker, that said a lot of people are moving away from religion, particularly the very formal Roman Catholicism and so on, where there's a lot of rules and regulations, and they're becoming more what you might call spiritual, but not religious, but even not religious. And they are turning to things like UFOs and other sort of non-earth bound things, because people do have a need for some higher power or something else out there. And if religion doesn't do it for them, they might actually say, yeah, well, they'll take that part of the brain that likes religion, and it will become devoted to UFOs or other things that might be supernatural, or who knows. So, yeah, Denise.
Isn't there a group like that in Quebec? Is it Les Bérets Blancs or something? A group that...
The Raelians.
The
Raelians.
Right.
Oh,
right.
Believe in extraterrestrials.
Yeah.
I think, yeah, I've heard of them.
Yeah.
Well, that could be. That could be.
The master or the leader of the Raelians, his sister said in an article years ago that he just started this to get girls.
But they had come to our class, Don Dunderry's class.
They did.
Brilliant.
Okay.
Yeah.
I couldn't remember the name.
Great tip, Howard. I appreciate that.
Yeah.
Although at my age, it's not that useful.
Yeah. Well, the people get together for all kinds of reasons.
Yeah. Never say never, Frank.
Yeah. But this, if you have Netflix, look for Behind the Curve documentary. And there was a lot going into the psychology and what they get out of it. And there was even a couple of instances where the flat earthers wanted to use scientific instrumentation to prove that the earth was flat. And it showed examples of 2 experiments they did. And unfortunately, the experiments proved that the earth wasn't flat. But they just said, oh, well, there's a problem with the equipment. Well, next time we'll get it working properly. And so on. So you got to think of the mentality of somebody who believes that.
So at the beginning, you said, you asked us the question, how many of you, your question? Be interesting to see if we've changed our minds.
Oh, okay. Tell you what, I can do this.
Yeah.
I can do this.
Cool.
With who's left? Okay. Do you believe that extraterrestrial beings have visited Earth? Wow.
Change of minds.
The yeses, actually the yeses are still there. The no's have gone down and the I'm not sure have gone up. But I'll give you the results.
Yeah.
What was it before?
So
41% or something?
More
I think it's changed. I think it was 21 who said yes. Those people have, well, it's hard to say it's the percentage. A few people have left, but I think there are more. I'm not sure. So, well,
Half as many.
I wasn't expecting to change any minds today. Don't worry about that.
But it's interesting, Tim. Really great. Really, really great.
Yeah.
Thank you very much.
Thank you very much, Tim.
Yeah.
It was really good.
Okay.
Oh yeah, it's really, really, really good.
I'm impressed.
All right.
I'll be watching
Thank
the
you very much,
skies tonight.
Tim.
Glad you enjoyed it.
Yeah,
Yeah,
excellent.
see you, Tim.
Outstanding. Outstanding.
Yeah, yeah, it's really interesting.
Bye.
Time went by so fast.
Bye.
Bye, everybody.
Bye.
Bye, everybody. Stay safe.